Hi everyone, my name is Ali and I will be teaching the course Collaborative Design and Development with Arduino. And in this course, we will explore various electronic components like a resistor, capacitor, microcontroller, and etc. and get familiar with C programming. Together, we will build exciting and funny projects using the Arduino board and I will do my best to explain everything in the simplest way possible. So even if you have no prior knowledge of electronic or C programming or any other programming language, don't worry. You will be able to follow along easily. Okay, today's agenda first, I will introduce the course structure, explaining how grading and assignment will work. Then I show you some of the project I've worked on so you can get a better sense of the practical application and the experience I bring to the course. And then next we will start exploring different electronic components, what they are and the role they play in a circuit, like what's the capacitor and what's the role in the circuit. And after that, I will introduce the Arduino IDE and explain how to use it. We will also define some simple project and work on them together. And finally, in our in-person session, maybe during week, we will build and test these projects hands-on. So our goal in this class is to take over idea and turn them into the real project in the easiest way possible. So if you have a specific idea that you would like to bring to life and it requires both hardware and software design, you can use what you learn in this course to make it happen. About course structure, every lesson will consist of two parts, practical and theoretical. So we will begin with a theoretical lecture followed by a hands-on practical session to apply what you have learned immediately. So for example, I will introduce the ultrasonic sensor, what it is, and how we can program and connect it to Arduino board. Then I will ask you to make, for example, a digital meter that measure distance without contact. About your final grade, it consists of two parts, your assignments and your final project. 70% of it is for your assignments. Every 2 weeks you will receive a practical assignment to work on individually, but actually it's maximum 4 projects or 3 or 4 projects. And 30% of your final grades is goes to your final project, and the final evaluation will be based on a project which you will design, build, and present. If you have any other question about this part, you can email me and I will answer it to you. I will reply it. Okay, I'm going to introduce myself shortly. I got my bachelor's degree in electronics engineering and a master's degree in mechatronics and robotics. And actually, I developed a passion for electronics at the age of 13 and have worked in this field for the past 14 years, now 15 years. My experience includes a range of projects focused on microcontrollers, sensors, robotics, and embedded systems, and designing PCB. I'm going to start with the simple project that I have done around 10 years ago. The first project is measuring load cell voltage with 20-bit accuracy. This board is designed for accurately measure the weight of diamonds and gold. It can measure the weight of object with high accuracy, and the PCB and programming of the device I did by myself. A PCB, or a printed circuit board, it's this board. See this board we called it PCB, or printed circuit board. That actually is a board on which connection made of copper or gold, this connection or other connections, depending on the design requirement. For example, if it's the high speed things, or for example RAM, or etc., they use gold for the connection. Or for example, this device is a general device, we can use copper for connections. So, and for producing the PCB board, first I designed it on in some software like Altium Designer, and so I designed this board in that software, and then send it to the company that produced this kind of PCB, and they print this connection on a board, and I can solder this component, electronic component like ICs, microcontrollers, resistor, capacitors, and push buttons, regulators, and other component on this board with soldering. In the future, we are going to get familiar with this device, capacitor, resistor. What's the capacitor, resistors, or and other components, and we will get familiar with the soldering. The second project is measuring and controlling DC motor torque and power with torque curve plotting. Uh, it's actually one of my undergraduate course, which is to control the speed and acceleration of motor. For example, you want to build a robot, and this robot has to work at different speeds, so you have to control the speed and acceleration. For example, somewhere the robot should move slowly, and in the other where it should be faster. So with and actually it's a laboratory device to display how this speed and acceleration change on the LCD. And the on the 7 segment, we call this 7 segment. We will have some project with this component and LCDs and push buttons and multi-turns. You are going to be familiar with this type of component in future. So if you don't know what's the name of this and how is it working, don't worry about that. Is STM32 microcontroller header board. We call this board a header board, and I used STM32 microcontroller. It's a ARM architecture that is high speed and advanced microcontroller compared with AVR microcontroller that used in Arduino. So this microcontroller is advanced than Arduino's one. And the header board, I mean this board is basically a PCB that comes with the microcontroller and the essential component needed to microcontroller get up and running. So you can use this header board for it makes it much easier for students and developers to work with the microcontroller. So, and it's actually similar to an Arduino board, which we will be using in this class. And so actually Arduino is a type of header board. And I designed and produced this board when I was 19 years old, and I made 100 of them. thinking maybe I would get rich, but unfortunately I only sold 10, so my first attempt at making money didn't really work out. So the other board is environmental monitoring board, temperature and humidity with SMS reporting. I designed this device for someone who was growing edible mushrooms, the kind you can actually eat, not the fun ones. So the idea was to let them remotely control the temperature and humidity via SMS. And if needed, they could turn the heater, humidifier, or other equipment on and off without being there in person. And in the future, we will have some project like this. You can control the lamps or other stuff remotely. Okay, the other project is a CNC machine for pen writing, and as you can see in the video, it writes the words on the paper with this pen. And I designed this device using a 3-stepper motor. We will get know what's the stepper motor in future, so don't worry. And I used Arduino board for controlling them, and I also worked on Persian script, as you can see here. So the machine can directly write a Persian text as well. I tape it on the motor, so it's not professional, but it's working well. Is a 8-channel controller board with RS485 serial communication. It's a type of communication in microcontroller, so don't worry, again, we will know, you get familiar with that. And this board is designed for the pool locker, so when you go to gym or pool, you put your clothes in the lockers. This kind of board control them, and I designed it for the pool. The other project is 16-channel controller with Bluetooth, Wi-Fi, and Nokia display. Actually, in a university bachelor, we designed a quadcopter that can fly. So I designed this controller to remotely control the quadcopter with Bluetooth or Wi-Fi and the Nokia display, because it's look like the old Nokia phone LCD in electronic. We called it Nokia display. Okay. Sixth is the design and construction of robotic mechanics for navigation, small diameter tubes with angle over 90 degree. So I'm going to be silent, just see how the robot go through the pipe even with the 90 degree angle. I used Arduino board for controlling it. Okay. My younger version at a robotic club of Besh University. We worked on some robotic things. Okay, in this project, I have designed a potentiostat. We call this device potentiostat, a device used for testing electrochemical properties of materials. So actually, it operates with an electrode. We put it over here, where a chemical sample is placed on that, and then measures and they plot the current voltage characteristics over here. And this potentiostat I designed, both hardware and software capacities are very advanced, and user can adjust various parameters such as for example, the current measurement range or output voltage range, and it's very high precision, and it's ideal for accurate experiments and scientific research. And I use maybe 10, at least 10 op-amp. We call this ICs op-amp. Maybe in future we will be familiar with them. A microcontroller and the capacitors and other stuffs over on the PCB board. Let me stop it. Okay. This is a voice announcer and music player used in elevator. I um, developed it for Persian musics. It contained an SD card and 7 segments and other stuff like microcontrollers is an essential component of our boards. Let me explain a little bit about the microcontroller because I repeat it a few times. Actually, a microcontroller is a small computer on a chip, IC, where we will program our code to control other stuff. So we will write a code, for example, in Arduino IDE, and then compiler will change our code to the assembly, and then we will upload our code on the microcontroller to control output, inputs, and other sensors. So now we know what's the microcontroller. So in every digital embedded system, if we want put our code on that, we should use microcontroller. Maybe we can use other stuff like FPGA or other control units, but in our course we will focus on the microcontroller. The easiest way to upload our code on that and control other stuffs. And so this is the other project. Let's listen the music. For example, to analyze the floor and the change music and continue the Okay, this project is hand sanitizer device for pandemic COVID-19. I designed and produced and first link. So when you put your hands on the device with the ultrasonic sensor, we will get now what is it and how is it working. The device detects the object, in this subject our hands, and start to spray the alcohol on the hands. Okay, this device is for monitoring and optimizing electricity production with solar panel. I developed a board, this device with the Arduino board. So the Arduino board senses the current and voltage of solar panel, and to set the angle of the solar panel to optimize the electricity production. This is the 3D printer that I design and build and customize it by myself. I designed the mechanical, electronic, and software parts by myself. And it's very accurate 3D printer I built in home and used for other project. And so I used four stepper motor and drivers and Arduino board for that. So we will get know what's the stepper motor, how is it working, and then what's the driver for that for them, and then with some knowledge of electronic and mechanic and programming, you can build your own 3D printer and print all of the stuff you want. Let's watch the video of the this product. Okay, this board is a smart alarm system for vehicles. The board has a GPS, microphone, and the SIM 800C modules to connect to internet and get SMS or send SMS. A microcontroller and the gyroscope sensor and the relay for the output. So with this device and installing it in your vehicle, you can control it with SMS or internet to turn it on and off. And if your vehicle is stolen, you can track it and control it. For example, you can turn it off. It's kind of a smart alarm system for old vehicles that I designed. This is our robotic group in Beige University that grew up, and we worked on the human robots and the quadcopters, as you can see. Okay, this project is automation of ice gel packing machine for medical application. Powder and the water are measured with specific weight through this and poured into nylon things and packaged from here. I designed this part. As you can see, the interface, touch screen, inverter for the motors, thermostats for the this part and this part. It can produce 80 pack per minute. Okay, the other project is design of electronic board for postal package station in Iran, my country. As you can see, I designed this board to connect the lockers to control them. You can put your package in it or get your package from it, like the pack station for DHL in Germany. So I designed this electronic board and touch screen things and collecting data or sending to the cloud and other stuff for the post company in Iran. This is the relay extension board supporting up 496 relay with CAN bus communication. It's kind of communication. Each one of these outputs goes to the one device to control them just with the three wires. We can extend it more than 1 or 2 kilometers to control them with a wire. Actually, we can use it in a specific situation, not everywhere. So I just design it for a company needed for their lockers. As you can see, every time one of these relay and outputs is going on and off. This is the main elevator control board, and I designed for a company. So every elevator in the world use this kind of control board. It's very complex because a lot of safety and sensor comes to in this board. This board should control all of them. And this board I designed can support up to 50 floors. As you can see, a lot of wires over here. Each one goes one to one of sensor, and the board should read the sensors in real time for the safety.
Ya aşağısı.
Okay. Okay, this is the 2.2 kilowatt emergency power system for elevator. We call it UPS. This board is useful when you are in an elevator and the power is gone. So this board is start to produce the electricity with the battery, the 12-volt battery we connected over here, and in the output we will have 220 volt as home's electricity power. So we can turn the electromotor of the elevator to the closest floor to save people maybe stuck in the elevator. Okay, this project is 7.5 kilowatt 3-phase inverter for AC motor. It's the most challenging industrial project I have undertaken, and I think it took around 3 years of me to finish it. I designed in 3 different versions. The inverter is a device for controlling of speed and torque and power and acceleration and deceleration of electromotor. In this project I designed the inverter for elevator. Actually, inverter is a, if you remember, maybe 10 years ago, or in some old building, and you want to use the elevator, when elevator want to start or stop, you feel the shaking. It's because that elevator doesn't have a inverter, and today's because all of the elevator has the inverter, this kind of things. You feel the smooth moving and stop. So it's the one of the necessary thing to install in the elevators, and I designed to produce for a company, elevator company. So the other project, okay, and the project is the last project actually. It's a non-contact device for measuring liquid flow energy through pipes using ultrasonic waves. This is a device I designed to measure liquid flow inside pipe using ultrasonic waves. Ultrasonic waves are high frequency sound waves often used in devices like medical ultrasound for imaging, the babies inside the womb. So the principle is similar. So as both measure how waves interact with fluid or materials or baby maybe, I produced this device and even started a company to manufacture it. But unfortunately, it didn't succeed. And in this course, we will learn more about ultrasonic waves and we will build a practical project like an electronic measuring tool to better understand this technology. Now I'm working as a PhD student and researcher in TU Berlin with Professor Sharmin. So the first device I built, it was pinch and grip force measuring device. I used load cell in both of them to collect force from people to use this data in our algorithm, machine learning algorithm. So that was the first, and now I'm working on EMG and PPG sensors. So that's it. Now, okay. Well, first, first of all, let's start by looking at what an electronic circuit is and what we actually call an electronic circuit. In fact, an electronic circuit is a combination of a series of electronic components such as resistor, I don't know, capacitor, inductor, diode, transistors. And the purpose of designing an electronic circuit is that when we give it an output, an input, we actually expect an output from it. Okay? So, and this circuit can produce that output, which can be voltage or current for us. Okay? So for example, we have a signal that we want the microcontroller to read, for example, analog signal or even the digital signal. And but since its current and voltage are very low, for example, EMG signals from the body or a load cell signal, the signal comes from the sensor, weight sensor. It's very weak, so we need to amplify it. So as a result, we design a circuit that amplifies these signals for us to transfer them to the microcontroller, and that microcontroller can read that data. Or another example, when we have a series of data that we want to send via a wireless circuit such as Bluetooth or Wi-Fi, we need to design the circuit and drivers for various modules. For example, Bluetooth module like HC05 or for Wi-Fi ESP32. These modules need some drivers. So we need design a circuit for them, and so that's the circuit. So if we put some electronic component like, as I said, resistor, capacitor, inductor, diode, transistor, or etc. together to do a specific job, we called it circuit. Voltage is the potential difference between 2 points in a circuit that causes electronic to flow through the circuit. To clarify the issue, compare it to two water tank, one of which has more water. When we connect them to each other through a pipe, Water flow from the tank with more water to the second tank until they reach the same height of water, for example here, meaning their potential difference reach zero. And batteries or power supply in electronic circuits actually act as two tanks, one filled with a water, like this, we called it the negative pole, and the other empty, the positive pole, which cause electrons to move from the negative pole to the positive pole. So when we say battery is discharged, it means actually the potential difference between its positive and negative pole has actually become zero. So, and the unit of measurement for voltage is the volt, named in honor of the Italian scientist Alessandra Volta, if I if I am correct, Alessandra Volta. So that's it. So what is resistance? Um, we want to see what a resistor or resistance does in electronic circuit. In fact, a resistor, the device act as for resistance, is like a valve that controls the amount of current in electronic circuits. In fact, for an electronic circuit to meet our demands and expectations, we must be able to control the current, and this is done through a resistance. So we need resistance to control the voltage and current. Okay, we have learned about voltage and resistance in electronic circuit. The next thing is current. Electronic current is actually the amount of electrons that are transferred from one point in the circuit to the another. This means that if more electrons are transferred, we will have higher current in the circuit. So more electrons, higher current. And you can now see all three of the things I introduced in the figure: voltage, current, and resistor. We have a tank with a water level, the water level equal to the voltage loss. We have a valve and or tap, I don't know, valve that shows the resistance uh, for us, and the amount of water that comes out of the pipe here determines the amount of current for us. So we have three of them here: voltage, resistor, and the current. So if we open the valve more, which is a symbol of resistance for us, as I said, it means reducing the resistance in the water pass. As a result, we will have more water will flow from here. So it means more current in electronic circuit. We know the water's flow here is a current for us. If we open the pipe or valve more, we will have more current here. So we conclude that if we reduce the resistance value, the current in the circuit will increase. So combination of these three, I mean the voltage, current, and resistor, it's a very important law for us. We called it Ohm's law. We, um, as I said, Ohm's law is a very important law in electronic circuits that consists of voltage, a resistance, and current, where voltage is equal to resistance times current, and this equation is always true in all of circuits, and the unit of measurement for voltage is volts, current is amperes, and resistance is ohms. In electronic, we generally have two categories of component: active component and passive component. Components that require a driver or trigger to activate, we call them active components, such as some semiconductor devices, transistor, diodes. While passive components do not require external voltage or driver, such as capacitor, inductor, resistor. And passive component can be placed in a circuit without any driver or trigger, and they can do their job, while active components such as a transistor, as I said, require a driver to turn on. For example, for transistor we need we have to trick the bias pin in the transistor. For example, we will get familiar with that in future. So now we will get familiar with the most famous and simplest electronic component, which is a resistor. The resistor is actually a two-terminal component, as you can see here with the symbol. And because it is a passive component, its terminal are no different from each other, and so we can place it in the circuit in any way, meaning it does not have a positive or negative terminal. And so it's an electrical component that limits or regulates the flow of the electrical current in an electronic circuit. If you remember the tongue things and the valve, we can control the valve, so then we can, because of that, we can control the current. Resistors act as a valve in our circuits. So resistor can also be used to provide a specific voltage for an active device such as a transistor. So if we want to have a driver for our transistor or any other active component, we can use a resistor to provide that voltage. And the symbol is like this in the circuit, and the unit is ohm or kilo ohm. It means 1000 times ohm, or mega ohm means million times ohm. And we have different types of resistor in electronics, such as fixed resistor and variable resistor. And the fixed resistor, such as carbon composition resistor, metal film resistor, wire wound resistor, carbon film resistor. And for variable type resistor, we have potentiometer, trimmer, thermistor, light dependent resistor, and varistor. The most common type of fixed resistor is carbon composition resistor, and in your kit we only have this type of fixed resistor, and we will use this, and it's very general in electronic. And in general we have two different package of electronic component. We call them SMD or SMT sometime, and DIP. DIP means dual inline package, and SMD means surface mount technology or device. So in this is the SMD one. SMT or SMD, it's the same. There's no difference. And we use, they are very small, and you can solder. They don't have a physical pin. You should solder it in the surface. But the other one, it's like this, and they have a pins both side of them, or this one, all of these are, we call them DIP, and we will discuss about them in person, our in-person course. So just for now, you should know we have two type of electronic component. Just for now, DIP and SMD, and of course each of these resistors has different uses. For example, metal film resistor can be used for measuring specific current and small current, or other resistor. And for the variable resistor are actually resistors whose resistance value we can change, just like the valve with which we can increase or decrease the volume of water in the tanks, if you remember. In this resistor, we can change the resistance value by turning a screw or making physical changes. For example, a potentiometer or trimmer, this is potentiometer and this one is trimmer, have a screw like this or something like this that we can turn to change the resistance value. So with turning this screw, we can change the resistance between the pins. We will have some project on them, so you will get more familiar with them in a practical project. And or we can change the resistance value by physical changes. For example, a thermistor whose resistance value change with temperature, two different type, NTC or PTC. NTC mean negative temperature coefficients, so with increasing temperature our resistance decreasing, and the opposite side it's PTC, with increasing temperature our resistance start to increase. And or the LDRs, or light dependent resistor, we call them LDR, whose resistance value change with changing light. So with changing light, the resistance between two pins will be changed. And the other one is a varistor, and the resistance of that will be changed with changing voltage between two pins. And so we call these resistors that change with physical conditions sensors, and in the future we will do different and interesting projects together with this type of sensors. As we already discussed, resistors act like valves in electronic circuits. They have three main functions: limiting voltage and the current, and for power dissipation. We will discuss about the current and voltage, and but maybe you may be wondering why we should waste power. In electronic circuits, we need to reduce some of the power that can damage other component. I don't know, for example, if we want to turn on an LED, we need to limit the current, of course, which causes some power to be wasted in the resistor and converted to heat. So resistor has three main job. The first one is limiting of current, second one is limiting of voltage, and third one is power dissipation. Okay, we can connect resistors in two main ways: a parallel and a series. In series, if we connect them, it is enough to add the value of the resistor together, and the equivalent value of the two ends of these resistors is equal to the sum of all of them. As you can see, we just need to add them together, R1, R2, R3, R4, and the equivalent of the two ends of the all of resistor is this. and but in parallel they must be added together in reverse order, which reduce the equivalent resistance value. As you can see, if we want to know what's our equivalent resistor, we need to add them in reverse. And as you can see, in series mode, since there is only one pass for current to pass, the current remains constant because there's just one. So if we have a current over here, it can just go through in this pass. But the voltage across each resistor decreased because the voltage is divided between each resistor. And however, in parallel mode, since the current finds several new paths, as you can see here, the current is divided between several passes here, here, and here, so it should be changed. But the voltage remains constant because the voltage is directly connected to the two ends of the resistor as before. So in series, this one, the current remains same, but in parallel combination, the voltage remains same. Okay, well, for example, here we want to calculate the equivalent resistance value, and actually from A and B, we want to see what equivalent resistance we will have from the combination of parallel and series resistor. So here, if I should change every time, okay. Here, if you look at these three resistor, we see they are in the series combination, see? So we just need to add them simply together. So the equivalent of this three is I name them R equivalent C and D. Okay, so 3 plus 3 plus 3, it's 9. So our circuit now it'll look like this. So this 9 ohm comes here, this 3 ohm comes here, the same the last one. So and the other 3 and 3 comes here. So 9 ohm, 3 ohm, 3 ohm, and 3 ohm. So now these two are in parallel combination. So we need to use the formula. It was like this. So we can simplify it like this. R equivalent, it's I want to reverse it, just a simple mass. So it should be like this: R1 times R2 divided by R1 plus R2. Okay, so we just need to put these two 9, let me show, just 2 9 and 3 ohm in this formula as a R1 and R2. For example, R1 is 9 ohm and R2 is 3 ohm. So if we calculate it, it's R equivalent, it's now times 3, 9 plus 3, it's 12. So equal 27 divided by 12. So our circuits look like this now. 3 ohm, 3 ohm, and 27 times 12. So this 3 ohm is this one, this 3 ohm is this one, and equivalent of this 4 resistor, it's 27 divided 12. So now we have the 3 resistor in series combination, and simply we need just add them together. So R equivalent for all, I mean A and B pins, 3 ohm plus 3 ohm plus 27 divide 12. It 27 divided by 12, it's around 2.25 ohm. So 6 plus 2.25, 8.25 ohm. So if we measure the resistance from here and put the, for example, multimeter, the device we can measure the resistance, one connector here and another here, we can see the 8.25 ohms on the screen. So we calculated. Well, to read the value of the resistor from body, they don't directly print the resistance value number on the body, and that's why we need to read the resistance value from this color coded numbers, and these colors look like this, as you can see. First, we should note that we should start the color values from the direction where the 3 colors are close to each other. So, and not from the one that is far away. As you can see here, we should start reading value of the resistance from this side with this direction. And the last number is a tolerance value. So, and some resistors have 4 and some have 5 color. For example, this one is 4 bands. We call them band, 4 bands resistor and 5 bands resistor. In 4 color resistor, the first and the second color represent the number, and we must directly find the number from the colors and write it down. And the third color represent the number of 0, and as I said, the last color represent the tolerance. But in 5 color resistors, the first 3 colors represent numbers which we must find and write from the color here, and the fourth, this one for example, here is a red, fourth color represent the number of zeros, and the last color represent the tolerance. And for example, in the 4 color resistor above that we see, the first color is green. It shows the, as you can see here, number 5, and the second color is blue, which shows the number 6. We write them, so 5, 6, and and the third color is orange, as you can see, and shows the numbers of zeros. So we should put 30 there. And the last color is gold, shows the tolerance value. So the tolerance is 5% here. So we have 5, 6, 3, 0 and 5% tolerance. It shows 5, 6, 3, 0, and it means ohm. And if we can say we have 5, 6 kilo ohm with 5% plus minus tolerance. So the tolerance indicate the amount of error in resistor. For example, if our resistor is 1 kilo ohm, for example 1 kilo ohm or 1000 ohm, let's say, let me change the color, and our tolerance, if we suppose it's 5%, for example, plus minus, well, we know that 5% of 1 kilo, 5% of 1 kilo or 1000 ohm is 50 ohm. So the actual value of our 1 kilo ohm resistor can vary between 950 ohm and 1050 ohm. So if we read the resistor with multimeter, we can see, for example, 1020, and in the other one we can see 970. Because of the tolerance, it's not exact and accurate resistor, but in the sum of them, the tolerance is 1%. So for example, again, for the 1 kilo ohm one, we can see 1000 ohm plus minus 1%. It means it's from 990 ohm. It can vary between 990 and 1010 ohm. It's more accurate than 5%. So actually, we will practically measure the actual value of resistors with a multimeter and ohm meters in in-person class, so you can feel it and see what's going with this kind of numbers. So here we see a combination of parallel and serial resistor. So this 3 is in parallel, and other these 2 and with this 3 in series. And I want you to find the value of the resistor based on the color of the resistor from this table, and then find the equivalent value of the resistor from these 2 ends, here and here. Capacitor. A capacitor is a device for storing electric charge. A capacitor is a passive electronic component consisting of a pair of conductors separated by a dielectric insulator, and when voltage is applied across the plate, capacitor stores charge and can release it when needed. The symbol in the circuit is like this. We have 2 different types of capacitor: non-polarized capacitor and polarized capacitor. If we want to use capacitor in our circuit, if it's polarized, we should put in a right direction in the circuit. For example, we should connect the plus pin or positive pin to the positive voltage and minus pin or negative pin to the ground or the negative voltage. And if we put in the wrong direction, it's gonna destroy it. And we will test it in the lab together, see what will happen if we put in the wrong direction. Capacitance, this is a measure of a capacitor's ability to store charge. For example, we called it, for resistor we called it resistance. Now for capacitor we called it capacitance. A large capacitance means that more charge can be stored. Capacitance can be measured using formula Q, means the charge equal C capacitance times by potential difference. Here we write it. And unit of capacitance is farad, because farad is a too big number. We use pico, nano, and microfarad. For example, picofarad means 10 to minus 12 times farad, or the same for nanofarad and microfarad. We have two different type of capacitor: polarized capacitor, non-polarized capacitor. For polarized capacitor, we should put it in the right direction in the circuit. The positive pin to the positive voltage and negative pin to the negative voltage, and we will learn how we can put it in person. So don't worry, which pin is negative, which pin is positive, we will get to know that. And the electrolytic capacitor and tantalum capacitor are both is polarized capacitor, and ceramic capacitor, film capacitor, mica, polymer, and paper is kind of non-polarized capacitor. And in your electronic kit you have electrolytic capacitor and ceramic capacitor. This one is electrolytic capacitor, tantalum capacitor, ceramic capacitor, film capacitor, mica capacitor, and paper and polymer one. Electrolytic capacitor used for high capacitance value, often in power supplies, and ceramic capacitor is small, low capacitance, used in signal processing. And this one is a tantalum capacitor. It's known for stable capacitance over time and often used in precision circuits. Okay, connecting polarized capacitor. It's very important thing. So you have to put your capacitor in right direction in the circuit. So positive to positive and negative to negative. And the voltage limit, you should ensure the voltage does not exceed the capacitor printed rating. There is a number for voltage on the capacitor, for example 16 volt. You shouldn't put your capacitor in 20 volt circuit. And if you put in incorrect polarity or over voltage, can lead to overheating, leakage, or even explosion. You can see this video if it's played. Let me.
What's this?
Hey, Professor. This is Mikey. Will I be able to pass your class?
In your dreams, buddy.
Please, I beg you, Master.
What? No.
You shall get no mercy then.
Uh-oh.
That was a capacitor in a wrong direction and it's exploded. And the capacitor can connected in two main ways, like a resistor, series, and parallel. And the connection type affect the overall capacitance, voltage handling, and the behavior of the circuit as like um, resistors. So similar to resistor, where we easily add a resistance value together in series and add them in reverse in parallel. Now it's completely the opposite in capacitor, and it means in series combination we add together in reverse, but in the resistor we just add them directly together, and in the parallel combination we just add together, but in the resistor we add them in reverse together. And when capacitors are connected in series, the capacitance decrease because of this formula, and when capacitor are connected in parallel, the capacitance increased. It means if you want higher value of capacitance, you can put them in parallel combination together and use them. Okay, you have to read the capacitance of capacitor. Actually, in electrolytic capacitor are very simple because the capacitance value and the voltage are printed on them. But in ceramic or even the tantalum capacitor, it is through a code similar to resistors, which is very simple, of course, without the color. And it is like this, and the first and second numbers are written directly, and the third number here is 4 indicates the number of zeros, and the capacitance is calculated in the picofarad, and the last letter here is a K, indicate the tolerance of capacitor. For example, here is 1 0, 4 means 4 0 here in picofarad. So we can say, if we remove 3 of them, we can say 100 nanofarad, or we can say 101 microfarad, because we know every 1000 picofarad equal 1 nanofarad, and every 1 nanofarad equal to 1 microfarad. So here is some features of the capacitor. Capacitor offers low impedance to AC, and it offers a high impedance to the DC. AC or alternating current, it's the power of our homes in the plug. So if you put your charger in there or turning lamp on, it uses the AC voltage. It's in our house it's 220 volts, and the DC voltage is a battery's voltage or a direct current voltage. And capacitors shows low impedance. Impedance means kind of, we can now say it as a resistance, but it's combination of frequency. But don't worry about that, we are not going to go into details of that. So just I want to mention what's the feature of the capacitor. So if you have a, for example, you want to separate the AC signals from the DC voltage current, you can use capacitor to do that. And the application is blocking DC voltage, adjusting frequency, used to generate the time delay application, or smoothing of DC voltage. If you are interested about this thing, you can search and read some paper or article about that. A diode is an electronic component that allows current to flow in one direction and blocks it in the other direction. And it actually acts like a valve, one direction valve that only allows water to flow in one direction. And there is a lot of details about the diode because it's a base of electronic, such as, I don't know, the material used, for example, silicon, germanium, and PN junctions. But because our course is not exactly, we don't want to go into detail of the electronics, and so I just say the how does it work and what we should use them in our circuit. So the diode, it's a component like this. There is a two pin on that. One pin is anode pin and the other one is cathode pin, or a positive pin, negative pin. So anode, cathode. We show it with the line on the printed on the body, or in the schematics we show it like this line, the cathode pin. So if we put positive voltage here and negative voltage here, we called the diode is in a forward bias and it's active, and it allow to current go through the diode. But if we put negative voltage on the anode or here and the positive voltage here on the anode, it goes to block it. We called the diode is reverse biased. So we have forward bias and reverse bias in the diode. And we have different type of the diodes. For example, uh, general diodes like 1N4007, you have that diode in your electronic kits. The Zener diodes looks like this for voltage protection. We can use it. Schottky diodes or fast diodes, photodiodes like this one. You can find them in the remote controller for your TV or other stuffs. Laser diodes like this you can see in a lot of devices, they use the lasers. Or the famous one is light emitted diode or LED. Probably you hear that. Uh, this one is LED, it's just for light. So if we drive it in the forward direction, forward bias, it's turn on and start to emit light. And why we use diodes? Diodes are used for rectification. For example, if you have AC voltage, you want to produce DC voltage, you can use diodes. Diodes are used in electrical meters for their protection. Diodes are used in wave shaping circuits, and the diodes like LED are used in display. These are the different kind of LEDs. Okay, as I said in the last um, slides, there is a two terminal on the diode, anode and cathode. There is a silver band on the one side of the diode, which is cathode or negative terminal, and the other side is anode or positive terminal. And if we uh, put positive voltage on the anode and negative voltage on the cathode, we call it forward bias, and current can flow in this direction like this. But in the other way, if we put negative voltage on anode and positive voltage on the cathode, it's in reverse bias, then the current can't go through the diode. Okay, light emitting diode LED and operates in forward bias. It means we should put positive voltage. It means 5 volt, for example, with resistor. we should put on the anode pins or terminals, and the GND or negative voltage on cathode pins. So it start to emit lights when we connect it in circuit. And the symbol of LED, it's this in our circuit. So this is different color of LEDs. Okay, LED is a polarized um, component, so we need to recognize polarity. So it looks like this. The shorter lid of the LED is this one, is a negative terminal, and longer one is positive. Also, on the negative terminal, there is a flat spot when we see from the top like this. So it, uh, with these two, you can recognize the cathode and anode pins or terminals. Okay, I want to introduce the most important and widely used component in electronic, the transistor. A transistor is a semiconductor device used to amplify and switch electronic signals. It is made of a solid piece of semiconductor material with at least three terminals for connection to an external circuit. Three terminals, we call them base, collector, emitter. And a device with three terminals, where one terminal can be used to control the flow of current through the other two terminals. So with base terminal, we can control the flow of current through uh, collector to emitter or emitter to collector. Is a different type of transistor like bipolar junction transistor or BJT, or field effect transistor, FET, IGBT, HBT, UJT. This one is a BJT1. This one is a FET, IGBT, or HBT, or others. But in your electronic kit, we have just BJT1, and it's very general and useful. We will use it, and actually, in fact, transistors are used in all ICs. For example, in an IC 1 centimeter by 1 centimeter, there are millions of transistors in there. And there is actually a very high competition between the world's technology companies like TSMC or Intel or even Samsung to be able to make ICs with the smallest transistors. And currently the technology for making transistor with a size of 2 nanometer inside the IC is it is predicted that the size of 1 nanometer will be achieved by 2027, I think so. So imagine in the 1 nanometer there is a transistor, they design it, and they will put in the IC maybe 10 million of this kind of transistor in 1 centimeter to 1 centimeter. And because the BJT transistor, bipolar junction transistor, is a famous one, we are going to introduce it. It has at least three terminal. It's emitter, base, and collector. There is a NPN junction or PNP junction. We call, if it's a NPN, we call it NPN transistor, and if it's PNP, we call the transistor is PNP transistor. And there is some difference between them. For example, if you want to turn this transistor on, you should connect emitter to the, for example, GND, and put a little bit, for example, 0.7 volt on the base to turn this LED on. But for the PNP one, you should put a voltage less than emitter one. For example, if you put 0 voltage on emitter, you should put a minus 0.7 volt on the PNP one to turn it on. We will know about them in practical. You will use them, so it's okay, don't worry about that. And the NPN one is more useful. For example, in your kids, I think then the part number is 2N2222. I mean 2N 2222 one. So it's a famous NPN transistor. There is a thousand of transistor, different type of transistor. The part number, you can use it, and don't worry, we will use them in future. Okay, as I said, there is a two type of BJT transistor, NPN and PNP. You can drive them like this using with the resistor. You should calculate it, how much resistor you should put on the base terminal, and how you can connect the load to the NPN transistor, or if you have a PNP transistor, how you can use it. So in the practical, we will use them, so don't worry again. And this slide just for showing how is it work and the structure of the component in the circuit. We can use a transistor as a switch or amplifier or realizing logic gates. This is a circuit that for amplification. It's kind of driver for the sound. Used with the capacitor, resistor, transistor, NPN transistor, and PNP transistor, as you can see. And this circuit can amplify the sound from here, and you can put it in the speaker and use it. It's a 1000 watt amplifier. Okay, we will do the rest of the slides in person in class, because I want to work together practically and to be able to convey the concepts better. And this recorded tutorial was just to familiarize you with the basic components, and you will work with the components practically and understand how they work. I will see you in class in person. Bye bye.